Thank you for joining me today. We want to talk briefly about the tangent line approximation. So what you see here is the curve y equals the square root of x in black. And I have already drawn in red a tangent line to the curve at the x value of 4. And we know how to create the equation of that tangent line. And the way we do that is using the point slope formula. So we would do y minus y1 equals m times x minus x1. And the way you've done this in the past, your y1 here is the actual point. So this is the 2. The slope we need to find, but we know we find that by taking the derivative. And then the slope comes from where the first derivative is evaluated at x equals 4. So here we get 1 over 2 times the square root of 4, or 1/4. And the x1 is the x value of the point. And we have done this before, where we distribute the 1/4 and then solve for y. This becomes the equation of the tangent line to this curve at the point 4, 2. We do also know that if we were to move our point, we get a different tangent line. The slope of the tangent line starts flattening out as your x gets larger, or gets a little bit steeper as your x gets closer to 0. So for every point on that line, we have a different tangent line that is associated with it. What can be useful sometimes in applied problems is using the tangent line to approximate the curve. Now this curve isn't very complicated, but you could envision a curve that is very complicated, and that maybe you know its local behavior because you can analyze the derivative at one point, but you don't really know its behavior close to that. So maybe my goal at this point is to find something like the square root of 5. Using a tangent line approximation to the curve. Well, we know our tangent line is y equals 1/4 x plus 1. So if I want to approximate the square root of 5, I can do so by using this tangent line approximation. My x now is 5, so I'm going to plug in a 5 where I see my x, and I'm going to begin reducing. So this becomes a 5/4 plus 1, or a 9/4. And that would be an approximation of the square root of 5. It's not exactly equal to the square root of 5, but for the purposes of an applied problem might be very appropriate to use. You can see that this does match with, if I were to plug in a 4 instead of a 5, I would actually get 2. So the tangent line approximation is equal at the point of tangency to the function itself. Thank you for joining me today. Remember, if you're not having fun, you're not doing it right.